Hello everyone, I'm teacher Winnie. So today we will go through Physics SPM Trial 2024, Pahang Set 1 for Paper 1. So questions 1. Diagram 1 show a graph of P against theta. What is the relationship of the graph above? So whenever you all see straight line refer to linear. So if it going upward, so increases linearly. Let's say the graph is going downhill like that, then it's called decreases linearly. Now, if the graph exactly cut the origin, then we will say directly proportional. But this case, they don't cut origin, right? So that's why the answer will be increases linearly. The answer is B. Okay. Then question 2, which of the following is true regarding the motion of the car with constant velocity? Now, it can't move at constant velocity. That means, is there any changes in the velocity? There is no change in velocity. Okay, and therefore, they will be having zero acceleration. So for information, acceleration is rate of change of velocity. So like teacher say, constant velocity means example, the car is keep on moving at 80 km/h. Right? They never change in the speedometer, right? So you see 80 minus 80, you got 0 divided by t ma. So anything divided by 0, they're supposed to be 0 lah. Okay, because they are in motion, so they cannot be stationary. It's not a correct idea. And of course, increasing acceleration is also wrong lah. Okay, so move on. Number 3, what is the type of motion of a ping pong ball drop in vacuum? Okay, so when object drop, actually they consider experience what? Free fall. So that's why the answer is free fall motion. And free fall, particularly, there is no other force acting, especially air resistant, right? They only fall with gravitational force only. So that's the meaning of free fall. Number 4. Diagram 2 show a motorcycle, a car, and a lorry. If all transport move with the same speed, which comparison is correct for the time taken for the vehicle to stop at the red traffic light? So this idea is more towards the idea of inertia, right? So basically, if they are moving at the same speed, so if they want to stop, the one that have bigger mass, they will actually have higher inertia. So if they have bigger inertia, that means they need time or actually longer distance for them to stop. So that's why the time taken for the vehicle to stop at the red light, the longer time will be start with lorry, followed by car, and then followed by motorcycle. So we see which option, lorry, and then car. Okay, and then motorcycle. So the option is C lah. Number 5. Diagram show a boy riding a car before and after a collision with a table. And the mass of the boy is 20 kg and the mass is of the car is 25 kg. So what is the impulse produced by the collision? Okay, so what is mean by impulse? So firstly, you all need to know lah. Impulse, the symbol J, is basically the product of force and time, or is actually referred to change in momentum. So in this context, they do give us what? When the boy move towards the table, right? They have this initial velocity, and then after bang, they bounce back with the velocity of 1.8 meter per second. So we're going to use this equation. Okay, but before you all sub the equation, teacher always say, must check what? The unit, everything in SI unit not. And for information, under forces and motions, right, most of the physical quantity, they are vector quantity. So direction is important. Notice or not? So initially they move the direction this way. So generally we always assume positive lah, okay, toward right side, like number line. Then that's why when he bounced back, right, this direction is opposite direction already. So it's become negative. So you have to denote a negative inside the value. If you didn't do so, then later on your answer will be wrong lah. And then finally, the mass is 25. And we can actually factorize the mass as well lah. So therefore, you will have 25 negative 1.8 minus 2.5. And then you all press calculator lah and find out the answer. Okay. So you will actually get the answer as negative 193.5. or after your press calculator lah. And the unit follow lor. Okay, mass, the unit is what? kg, and then velocity is meter per second. Actually, same unit as momentum as well lah. Or sometimes if you use this equation, the unit can be Newton second. So this is some idea regarding impulse. Number 6. What will happen if the force exerted on an object moving with uniform velocity is increased in the same direction of its motion? So from constant velocity become increase. So basically the object will start to what? Experience acceleration, because they say increase that's mean increasing velocity. Now there is a change in velocity. You see A equals to V minus U divided by time, and now your V is increased. So it's higher. So you have positive answer, understand? Positive answer. So it's referred to acceleration. Number 7, diagram 4 show a parkour athlete bending his knee after jumping from a high wall. Which of the following is true about the situations above? So as you can see, when he jumped, right, he tried to what? Bend his leg, okay? So the purpose of bending his leg is actually to increase the time of impact, and then hence reduce the impulsive force acting on him or on his leg later on. So for information, impulsive force is equals to rate of change of momentum. Okay, this idea of this time is referred to time of impact or time of contact. So basically, their relationship is inversely proportional. So like teachers say, when he do this action, what means you bend, so the time is lengthened, therefore decrease the force. So we see which option is the best answer. Reduce impulse, not correct. It's impulsive force. And then time impact is short, wrong. Increase impulsive force, wrong. So lengthen the time. So the answer is D. Number 8. Diagram 5 shows below a rover with a mass of 1025 kg that landed on Mars. Which of the following statement is correct to describe the weight of rover on Mars? So for information, they want the idea of weight. So weight is basically affected by what? Gravitational field strength. So in this Mars, their value of G is basically smaller one, okay? It's about 3.7 meter per second per second. So because the value of this G is lower, so that's why your weight will be less compared to on Earth lah. So on Earth, G on Earth is how much? 9.81 meter per second per second. Yeah, so the answer here is B lah. Number 9. Which statement is correct? Describe Kepler's first law. So for information, Kepler's has 3 laws, right? First law is about the shape lah, shape, okay? They say all planet is move in an elliptical way, where your sun have to be at one of the 4 curves, either here or here also can, either side, okay? But we only stick to one because there's only one sun. Okay, so based on the given option, the correct answer will be B. And then A is nothing to do with any of the law. We go through C and D as well. The square of the orbital period is directly proportional to the cube. So this is actually referred to third law, Kepler third law. And lastly, D, a line that connects a planet to the sun sweep up equal areas in equal time. So this is basically the idea of second law, Kepler's second law. So at least you all recall back what is Kepler's law and try to remember the definition. Okay, number 10. Diagram 6a show a rocket is taking off from the surface of the Earth. And that the same rocket now is actually at moon as shown here. So which quantity will actually decreases, getting less? So basically same rocket, so they will have same mass. So if they have same mass, quantity that involving mass of rocket, mass of rocket, example of momentum, P equals to mv. P won't change, right? So that's why momentum won't change. Same go for the mass itself. And in terms of the idea of escape velocity, so now actually in this context, the scenario is they try to take off and actually escape from the Earth. right? So there is a formula for escape velocity, which is V equals to square root of 2gm over r. So this m is referred to mass of planet. This mass is not referred to the mass of the rocket. So generally, okay, the mass of the planet's moon is actually lesser, right? Mass for moon is less than mass of Earth. So that's why decrease, so your escape velocity is decreased as well. And linear speed, because now this context is not about the rocket moving in ellipticals idea to orbiting the moon or the Earth. So that's why it's not so suitable. Okay, 11. Diagram 7 show a wok used for cooking. Which of the following is true? So they are showing you two contexts. One is the body of the wok, which made by stainless steel. Another one is the wooden handle. Okay, so we can see the context for both idea. Okay, so generally, this is under specific capacity. So for information, okay, anything that act as heat conductor, easily conduct heat or easily heat up, that means their specific heat capacity, symbol C, is always smaller one. Okay, but then if the material that actually act as heat insulator, generally they actually conduct heat slower. So that's why their value of specific capacity is generally higher. So we're going to see through which option will be the suitable answer. So the specific capacity of stainless steel is less than specific capacity of the wooden handle. So this is the correct idea. No, this is not. B is not correct. And then the mass, not necessary because I didn't tell you the mass, so you cannot compare, right? You cannot make assumption as well. Okay. Question 12. Diagram 8 shows an air bubble moving to the surface of the lake from the bottom of the lake. And the water temperature is constant. So which is true about the above phenomenon? So actually this context involving what? Involving gas law in 4.4, Form 4 heat, and also a little bit on the liquid pressure in Form 5, Chapter 2. Okay, so I will say what, if involving gas law, we always draw this ice cream cone, P, B, and T. And the three side itself represent the three gas law, okay, which is Guru, Bahasa, China. Okay, so in this context, we have the context of volume. Volume, it changes. Understand? Volume increases. So we have the idea of volume. And then another context is actually the idea of pressure. So now we are talking about Boyle's law. Boyle's law. So Boyle's law said that what? Pressure is inversely proportional to the volume at constant temperature. If the temperature is constant. Okay. And as you can see, the liquid pressure being context now another context is pressure, but just say in Form 5. So under Form 5, right, liquid pressure. So your pressure is lower here, your liquid pressure, and the bottom, the liquid pressure is higher. What? Agree? Deeper the depth, P equals to H rho G. Okay, so that's why now we see what is the correct statement. Pressure is directly proportional to volume. Cannot I just tell you they are inversely proportional? Then as liquid pressure increases, volume decreases, correct? Not liquid pressure increase, what happened to the size of bubble? Smaller. So actually the answer is B lah. Okay, but we also go through all the options. C. Air bubble move to the surface of the lake with uniform velocity, not necessary. The volume of the air bubble increases as they approach the surface of the lake because pressure increases. Wrong, pressure decreases. Okay, so confirm is B lah. 13. Diagram 9 shows a student moving a slinky spring vertically. If the student increased the speed of the slinky spring, what happened? Also, generally, when you swing faster, it seems like, so what I mean, imagine also this is the initial state. So when you swing even faster, you will have more wave, right? That being produced, correct? So when the idea more wave, this idea is referred to frequency. So that's why frequency is increases. Okay, but nothing to do with energy. Energy is like they say you swing harder. So amplitude also will remain one. Okay. 14. Diagram 10 show a bat detecting a butterfly using a reflection of sound wave. Which of the following is true about the reflections of sound wave? So this idea regarding reflection. So teacher always say the phenomena of wave, they always like to talk about what is changes. Okay, is the wavelength change, frequency change, all this. Okay, so we recall back the idea first. So generally I always say reflection and also diffraction, right? They always will have same idea, frequency no change, wavelength no change, speed no change, but they change in direction. So now we see A, B, C, D. Which one is the correct option? So like teacher say, everything no change for what? For reflection and also diffraction, diffractions. So memang no, this one wrong lo, no change must supposedly speed no change ma. Direction change, wavelength no change. So the option is D lah for number 14. Okay, next one. Diagram 11 show 3 students on the edge of the building. Okay, only Ali can hear a clear sound from the speaker that emit from the sound wave with high frequency, but it means Abu Ali can't really hear clearly. So as you notice, this idea is the boy, they are standing at the corner and the corner. So the concept that involved, right, is basically diffraction, because under diffraction idea, they're talking about what? They're talking about the diffraction idea. Okay, so if you want all of the 3 boys hearing the sound from the speaker, right, that means diffraction must be obvious. So this diffractions idea, the diffraction idea is happen when your wavelength must be long enough. Okay, long enough. So generally, sound wave do have a long wavelength compared to sound. Okay, but then you see, what is the relationship between frequency and this wavelength? So generally, the relationship between the frequency and wavelength is when frequency is high, wavelength is less on. So that's why the context behind is due to this reason. Okay, so A, the effect of sound wave is more significant, not correct, because only Ali can hear ma. Then speed of sound decreases, also not correct. The effect of sound wave diffraction is less significant. High frequency produce short wavelength. Okay, so the answer for question 15 is basically this C. Okay, then we proceed to the next question. Okay, question 16. 2 loudspeakers are placed at the distance of 3 meters from each other and they vibrate at a frequency of 97 Hertz. Students find that the distance between the 2 consecutive loud sound is 5 meters and the velocity of the sound wave is 330 meters per second. What is the distance between the student and the speaker? Okay, so to solve these questions, you need to know the formula that involved lah. So this is under interference of sound wave. So for information, interference of sound wave occurs, they have a formula which is lambda equals to AX over D. And then you have another formula that needed. Okay, because let's see what is given in the question first. They say that's why you need to know all the context that needed lah. So loudspeaker placed at the distance 3 meters. So this is referred to A. This is referred to frequency. And then the distance between 2 consecutive loud sound is actually X. And they give you speed. And they actually want you to find what? Distance between student and the speaker, D. Okay, in the picture they give you everything. So you want to find D, okay? But you have what? A and X. Do you have lambda? There is no lambda in this context. So there's one more formula under wave topic that you can use the idea of speed to find out one, that it is V equals what? F lambda. So we want to find lambda. So lambda is V over F. So we do have what? FV. So that's why we find out lambda now. Okay, so it's 330 divided by 97. So press calculator, you're supposed to get 3.402 meter per meter for wavelength. Now you have ready law. So again, I rearrange the equation first. So we back to D equals to what? D equals to AX over lambda because we swap me. Clear? Then, so accordingly, A is 3.402. Then you press calculator, you're supposed to get the answer, which is 4.409. 4.409 is close to A. The answer for 16 is 8. Okay, so for the topic wave, right? Okay, now of course this question is good. Everything is in meter, okay, SI unit. So let's say it's involving interference of light, correct? So sometimes they may give you centimeter, they may give you millimeter. You all need to change all these prefix. So teacher tell you all the common prefix that used in this topic. So centi is 10 power of -2. Milli is -3 and micro is -6. So in case you all face these questions, you all use this prefix, makes everything become meter, then only sub into the region. 17. Diagram 13 show a result in the middle of forest, but still able to receive the signal of the mobile phone radio wave. What is the which statement describe the situation above? So again, we go through all the options first. Radio have large energy and easily spread out. Okay, they can spread easily is not due to the context of energy lah. So the idea of spread out means diffractions ma. So if you want diffractions to be obvious, we always relate with the idea of wavelength. Wavelength must be big. Okay, so we see B, radio wave propagate at higher speed behind obstacle. Also not correct because there's generally a travel at the same speed of, there are electromagnetic wave, which is speed of light. So B also not correct. Radio wave have a longer wavelength, thus able to diffract easily. Yes, actually this is the context, okay? So all the 7 electromagnetic wave are starting from radio wave. They're supposed to have the longest wavelength, then followed by all the wavelength decreases from radio to micro to infrared, then visible light, ultraviolet, X-ray, and gamma ray. Okay, but frequency is vice versa. Okay, then D, radio wave have high frequency, wrong also. So confirm is C lah, the answer. Number 18, diagram 14 show Amira stood at the bottom of the perspective pool. That means we have what material now? You have water, and then you have this perspective. And then actually Amira is in contact with air right now. Then she saw her brother who is swimming in the pool is closer than the actual distance. So which of the following describe the event? Okay, so let's look at number 1. The optical density of water is more than air. Actually, this is correct idea. Generally, okay, water is denser than air. Okay, part 2. The light ray from her brother are refracted away from the normal light. Actually, this statement a bit not so accurate or how to say hard to predict whether it should be true or false, in the sense that they didn't say the ray is refracted away from the normal light from perspective to water to perspective or water to air or perspective to air. Agree? Yeah, so if they mention the medium, then it's easier to capture. Okay, we see 3 and 4 first also. The refractive index of water is higher than the refractive index of perspective are not, because perspective is the highest refractive index. And lastly, part 4, the speed of light in water is faster than in air. Also not correct lah. In air is higher speed. Okay. Now, so just give you all some idea. By right, if the water from water to perspective means perspective is even denser, correct? So therefore, let's say there is a ray from perspective lah. okay, water to perspect. They're supposed to be what? Refract towards normal line. By right, then later on, between perspect and air, I need to draw a normal line again. But this case, there should be away from normal line and to even more away lah, because air is even less dense. So this is the correct idea. Okay, so the light ray from her brother are reflect away from normal line. So we assuming it is from perspect until to mirror lah. Then this one also can be correct lor. But actually a little bit confusing lah, correct? Normally we compare two medium water to perspect or perspect to air alone, okay? But generally if water to air, we skip the idea of perspect, it still seems away lah. Okay, number 19. Diagram 15 shows the image formed by a magnifying glass. Which of the following pair is true? So if you look at the characteristic itself, generally, okay, this is the image of a pen, correct? This is a pen cap, right? So they become magnified. This is no doubt already one, okay? And they're actually considered upright, okay, upright. And basically, they're supposed to be virtual lah. Okay, so in terms of the characteristic of image, this two is okay, this is wrong. Now, for your information, teacher always say one, okay? This magnifying glass, they are under the convex lens. Okay, so teacher always tell you all about the idea of boom, boom, ring, ring, straight, ring, right? So for your information, if this is lens, you have focus point, you have double focus point. Then I always say one, the object is less than focal length is case 1. Then at focus point, case 2. Then between, case 3. And then 4. And then 5 more than 2F. And lastly, at infinity is case 6. Then your characteristic is what? Boom, boom, rim, wrist. Same size, and then read, diminish, okay? So this is a very easy capture concept. So case 2 cannot is because the image is basically at infinity, very far away, so we can see it right in front of you, okay? So it's actually case 1, so that's why it is rim now. So we never have characteristic which is a real, upright, and magnified one, okay? Whether they are convex lens or concave, and then concave lens regardless of any position of object, right? Whether they are 1, 2, 3, 4, 5, all the case, they never change their characteristic. It's always wood. Okay, so for your information also, convex lens is also named as positive lens. Positive lens and also converging lens. Whereas concave, this is concave, they are actually called negative lens. And they are diverging lens. So why they're named positive lens? Because their focal length for convex lens is positive as well. So that's why based on the answer, okay, the answer is A lah. So hopefully you all can remember some of the important part on lens. Okay, question 20. Diagram 16 show a mirror dome located in Illinois, Chicago. Which of the following factor caused the formation of the image above? So as you can see, the people inside become smaller in size, diminish, right? Okay, then next, they are still upright. So for information, the general characteristic of image form is basically wood or virtual upright diminish. So again, if you always follow teachers' teachings idea or video, you will notice that I always mention one. If they have similar characteristics, so if they are mirror, then it's supposed to be convex mirror. Or if they are lens, then it should be concave lens. So in this context, my mind is the idea of reflection. So it's about mirror, so reflections, okay? So that's why this is the idea, okay? So there should be convex. So the object is at focal point or concave, cannot. The object lie at any position in front of convex mirror. Supposedly correct already. The object is lie between the focal point and center of curvature, not necessary, because you see any object this circle, they are far near, they always virtual upright diminish. So it's supposed to be any position. Okay, and this is for concave mount, memang confirm wrong. Okay, so it cannot only between a focal point and the center of curvature lah. Question 21. Diagram 17 show a man pulling a bag and the bag move in a horizontal direction even though the applied force is with an angle theta. What is the name of the process when a single force is split into two perpendicular forces acting on the bag? So actually this idea is called resolution of force. How we actually resolve the force. Okay, so firstly, what are the contexts will involve resolution of force? When we have the context of pulling, like this case pull, or sometimes you have the idea like lawnmower, you push the barrel or stroller, right? Downwards. So your arrowhead is being downwards. So how we actually do what means resolve a force. Okay, so we will actually from the tail of the force, we make it into x component and also y component. So we do have what? Fy, and then we do have fx. So basically, this idea will become the resolution of force, or we will resolve the force into the horizontal component and also vertical component. Question 22. Diagram 18 shows two steel springs with different diameter. Both springs are subjected to the same 10 Newton load, and it is observed that the extension of A is more than B. If you can extend easily or can stretch more, which means the general concept, the spring constant is low. Also, K for A is low, whereas B will be higher because your extension is less mass. So for information, spring constant is force per unit extension. So when your extension is less, your spring constant is higher. That means it's what we say a stiffer spring lah. We normally say stiffer. B is stiffer. Okay, so let's look at the idea. So spring constant of A is higher. Basically, they should write B instead of A, right? Based on BM. So the typo error lah. So we prefer BM because if not, A and B will be same statement. So the answer is actually A lah. So spring constant A is higher, wrong. Then elastic potential energy stored in B is smaller, wrong. So how we relate elastic potential energy? Elastic potential energy is half Fx or half Kx squared. So in the context of K, so it's higher. That means your energy stored is also higher. So when we want to compare the energy, we're supposed to make the extension constant X. Okay, then only we can compare. Okay, so number 23, diagram 18 shows a tube, U-tube filled with liquid X and Y, and the density of the liquid is 1300. Okay, so what is the density of X? So basically how we solve these questions is we're going to draw a horizontal line between the two liquid, or the separation of two liquid, or the boundary here. Then the next context is same point have same pressure. Next context, so the pressure at point 1 is supposed to be equal to point 2. Now, generally, both also have atmospheric pressure, but then because they're both exposed to atmospheric pressure, so I can cancel out, so I don't involve in this context, so I can just straight away use a liquid pressure idea. I will have H1 rho 1 G equals to H2 rho 2 G. Why G didn't put 1 and 2? Because they are on the same place, all the gravitational acceleration is same, so we can cut out. So your H1 is 13 cm. Your density 1 is what we want to find. H2 is 21.5 and the density 2 is 1300. So find out what is density 1. So finally, you're supposed to get the answer 2150. So the answer is B. Now, basically, this X is denser. Supposedly the diagram also got slight mistake. This liquid, right, they're supposed to be until here. Then baru more accurate idea. Okay, 24. Diagram 20 show a vacuum cleaner tool and a rubber sucker to pick up a glass sheet. What concept are applied by two tools? So for information, why we can actually clean up the dust is due to there is a fan inside that they will blow the air out. causing the pressure inside is low. Then higher atmospheric pressure will push the dust into the vacuum cleaner. Similarly, how rubber sucker work is we press and it force the air out and causing the pressure inside is lower. Then inside. Then outside, higher atmospheric pressure will actually stick the rubber sucker to the glass lah. So this concept is on atmospheric pressure. 25. Diagram 21 show the manometer connected to an oxygen tank where the value is turned on. When the valve is turned on. Based on the level of the liquid Y, which statement is true? So I always tell students, first, this is called manometer. So function of manometer is to measure gas pressure or liquid pressure also can. Okay, so for your information, if your armor is higher than the other side, that means you push more harder on the left-hand side. So what is the pressure on the left-hand side? It's come from the gas. Then what is the atmospheric pressure? The open end on the other side. So why it lower? Because the gas will be greater than atmospheric pressure. Let's say you have the same idea again. But then now the tube here is shorter, here is longer. Imagine. So who is greater? Of course, atmospheric pressure is higher. Then only you push it lower here, right? Then this one push up. So therefore, gas will be less than atmospheric pressure. It's like some common sense idea lah. So which statement is true? Pressure of oxygen gas is more than atmospheric pressure, correct? And then let's say, just for your understanding, how do you calculate the gas pressure? It's basically atmospheric pressure plus the difference of this liquid pressure, H rho G. So if in terms of cm mercury, let's say they give you a mercury liquid, so you just plus the length. It's just like doing maths, okay? Similarly, if they say they want you to find gas pressure, then you need to use atmospheric pressure minus the H rho G lah. So sometimes they give you in length, you straight away use the idea, like atmospheric pressure really fixed 76 cm mercury. So let's say they give you here is 10 cm. Mercury the liquid, so you minus 10 this one you plus 10 so at least you also know how to do calculation, because in this topic they particularly want you all to calculate. 26. Now diagram 22 show a boat that have a small leak in the bottom part of the boat with a hole. Water was found stagnant in one of the boat compartment. So and then using the appropriate principle of physics, which method would be the best for the boatman to quickly empty the water from the compartment? Okay, so A, the bottom boatman should use his hand to scoop the water. Is impossible because the water keep on coming in one, right? So not practical, the water is too much. Then similarly go for B, the boatman use a small water hose as a siphon. Okay, unless the water not keep on coming in, right? So also not so practical. Then the driver scooped the water using mineral bottles. And lastly, the boatman started the engine and drove the boat at a high speed. So generally, D is the best answer, whereby when you move at high speed, right, you will force the water to flow outward due to different what I mean, the water will flow out from the hole so this is a better option better option. Okay, then number 27. Which of the following is true about potential difference? So for your understanding, generally what is mean by potential difference in terms of formula used to define potential difference is actually work done per unit charge. So generally the definition is work done to move 1 coulomb of charge between 2 points. So the best answer is C lah. Now A, the rate of flow of charge is referred to the idea of current for your understanding. Then electric force acting on a positive charge at a point in electric field. This is an electric field strength. Region around is actually electric field. So that's why the best answer is C lah. Okay. 28. Diagram 23 show an electrical circuit that is connected to filament bulb. And if the bulb now is replaced by constant wire, choose the correct statement. So for information, indeed you all will actually do experiment regarding Ohm's law or ohmic conductor and non-ohmic conductor. So for information, filament bulb is non-ohmic conductor. So when you really carry out the experiment, you will get this graph one for the graph of V versus I. Now, if you were to change this bulb to become a constant wire, normal wire lah, constant wire. So the result that you get for V versus I is actually straight line. So whereby they obey Ohm's law and they are actually called ohmic conductor. This constant wire is called ohmic conductor. So from the gradient itself is actually equal to resistance. So this gradient is actually constant. So that's why resistance is constant when we change bulb to become constant wire. Potential difference unchanged wrong because you see based on the graph if your wire have high resistance, voltage is higher one. Okay, so it cannot be not changed. Then 3, potential difference is directly proportional to current. This is what I say, directly proportional. No, this one before is increase. And then voltage memang no. They say rate of change of voltage increases. Also wrong idea lah. We do not have the term of rate of change of voltage one. So it's like voltage per time lah. No quantity. So that's why number 4 itself is actually wrong idea. So that's why the answer is B lah. 29. 29 diagram show what? A circuit with 3 cells arranged in series. The same dry cell are then arranged in parallel. So if the EMF of each cell is 3 volt, then the current is 1.2 for 24A. Calculate the current needed for 24B. So they want to find what is I. Okay. So here they give you I equals to 1.2A. And then each dry cell, one dry cell is 3 volts. So now you have 1, 2, 3 dry cell. So 3 times 3, you get 9 volts. So you have the EMF, you have I, you have a big R. Okay. So what they want you to find? They want you to find I for the B. Okay, same thing. You do have EMF. They are parallel. That means they remain 3 volts. And then this is big R. Okay, so these questions memang involving the idea of EMF. If you were to notice, there is a formula for you under EMF, which is I bracket R plus little r. So what we actually want to find from A is we want to find out what is the internal resistance of the battery. Okay. Then why you need to find out the internal resistance of the battery? Because then only we will know what is the R in this context when they are in parallel. Then only we can calculate I. Okay, so that's why now we sub everything to get out the R total internal resistance first. So we have 9, 1.2, 6 plus little r. Then we can move on, 9 divided by 1.2 first. Okay, so 9 divided by 1.2, you will get 7.5 equals to 6 plus little r. Little r will be 1.5. This one is the total, total for 3 battery. So same idea, similar like bulb. If a big R series, that's mean you plus together. So battery in series, you plus together. So I want to find one internal resistance for one battery. I need to use 1.5 divided by 3. So I got 0.5 ohm. Okay, next, before you again do the same thing and sub into the equation for EMF equals to I plus big R plus small r, right? You need to find what is the R total. So this context is memang 1 over 0.5 plus 1 over 0.5 plus 1 over 0.5, 3 battery. And then they are inverse. Why is 1 over R? Because the formula, okay, for internal resistance in parallel is this one. For information, then you see I straight away inverse it. So you will have what? 3 over 0.5. Then inverse it, 0.5 divided by 3. And supposedly you get 0.1667 ohm. Okay, now we can sub into the equation. EMF is 3 only because they are arranged in parallel. Then unknown is I, big R plus small r, which is 0.1667. So I equals 3 divided by 6.1667. Hence, you can get the current. Also, this one, memang the working is more a bit lah. So you get C as the answer, 0.4865. So hopefully, all y'all can solve the question involving electromotive force. Okay, number 30. Diagram 26 show a dynamo on the bicycle, and the bicycle lamp will light up when the bicycle is pedaled. How to produce a brighter bicycle light? So for understanding, this dynamo idea is under electromagnetic induction, and involving the concept of Faraday's law, we state that the electromotive force is directly proportional to rate of the cutting of magnetic flux. So you want to have brighter bulb, which means more current flow. Okay, so based on the idea, either you increase the speed, you increase the number of turns, or you increase the strength of magnets. So A, use a weak magnet, not correct lah. Increase the distance between the magnet, also not correct. Increase the speed, yes. Reduce the number of turns, wrong, okay? So the answer for this one is C. 32. A transformer at Ulu Jerai Electric Power Station have a primary potential difference of 120 volt and a secondary potential difference of 480 volt, and it was found that there was a magnetic flux leak in the transformer, causing efficiency drop to 80%. So what is the current in secondary coil if current in the primary coil is 8 ampere? So for this case, you need to know the formula of efficiency in transformer. So formula for efficiency is out over in time 100%. Or sometimes we change the idea of power, right, into VI. So output means secondary, input means primary. Okay, so this is the formula that we use to solve this question. So again, we find out the information first. So primary voltage means VP. This one secondary VS. Efficiency 80%. Then this one, they want you to find IS. Then your IP is 8 ampere. Okay, so now you have all the information, no? Right, we want to find what? IS. And if efficiency we have, VS, VP, IP all have. So masukkan dalam equations, 80 equals to 480 times unknown, right back IS, no? Then your VP is 120, IP is 8. Then time 100%. So slowly, so you can move this up first, So 80 times 180 times 8 equals to 480, then more 0 lah, become IS. Up to you lah, the maths part, okay? As long as you know how to move. That's why I always say, when teacher already show you up to the formula part, you know what is the formula involved in which question. The next thing is you all have to try to do the maths part, because most of the time it's not about you cannot do physics, you cannot do the maths part. So you also need to know how to move the quantity here and there, factorization, all this, okay, until you get the answer. So 80 times 120 times 8. Okay, 76,800 divided by 48,000. So you're supposed to get 1.6 lah. So that's why if you do the maths part, then again it's not a big deal for you all. Okay, 33. 33, okay, you have this both diagrams show an experiment for diode connection in the two simple circuit. It's found that the bulb in the diagram 27A light up, and then 27B not light up. Which following statement is true for the experiment? So first you all need to know what is the type of connection involved. So generally, how we form a diode, we need to have a semiconductor. We have two types of semiconductor, N-type and also P-type. So N-type, they will have excess of electron. P-type, the excess of hole, okay? So generally, left side, this one is N, this is a hole. Also, this is P-type, this is N-type. This one also P-type, N-type. But the idea behind, you see the battery is in a opposite direction. Okay, so if you want to know about forward bias or reverse bias, okay, so in textbook, they actually mention what? When the hole and the electron can move across each other. Why they move across each other? Because this electron, they are negatively charged, they can drag and attract by the positive terminal. So that's why they have to move across. Whereas this p-type, they have hole. If hole got charged is positive, then they're supposed to attract by negative terminal. Okay, so that's why we say they move across each other. Okay, and why you see there is a gap here? This is called what? Depletion region. So when we connect in this connection, this is called forward bias. They move across each other. So they're causing the depletion region how? Thinner. But when I interchange the battery, p-type is still attract to negative if they can move, right? Then n-type, then they are moved away already. When they move away, what happened to this region? They increase, right? So that's why no current able to flow anymore. So your bulb will not light up anymore. And this connection is called what? Reverse bias. So let's go through ABCD again. Hey, the depletion region layer in 27A become wider. No, I already explained. Okay, it should be thinner. The resistance in the B is small, cannot. If they're small, then they can have current. It's very high. That's why the depletion region layer big means high resistance. High resistance. This one low resistance. Then the junction voltage is decreases. Wrong, I explained already. It become wider. Hole and electron is 27. They move across closer to the depletion radius. Correct. Actually move towards each other. So hopefully you all have some idea how diode work. Okay, with type of semiconductor. 34, diagram 28 shows a rectification circuit. So which of the following statement is true about the rectification circuit? So again, this is AC supply. When we have the diode in the circuit, we generally change AC to DC. So this concept is called rectification. And then we have two types of rectification, full wave and half wave. If 4 diodes, then they are considered full wave. If only one diode, then they will be half wave. And not only the idea under diodes, if you look at the circuit, we also have what? We also have capacitor. So the letter C with equal sign, you see in the circuit which arranged parallel one, that one is capacitor. So why we also add a capacitor in the circuit? So the function of capacitor is to smooth out the current. How they're able to smooth out the current? When there is a voltage, they will charge up. And then when there's no voltage, they will actually release the charge. So we look at the option again, A, B, C, and D. Which one is the correct idea? Okay, so A, capacitor function allow current to flow in one direction. Wrong. Why? It's not capacitor, it's diode. B, direct current convert to alternating current. Wrong. Terbalik already. The force stored in the capacitor will maintain the potential difference. They are not calling force, they are memang called charge. Then D, when the potential difference increase, the capacitor will charge. And then energy stored. Yes, this is the answer. 35. Okay, diagram 29 show an automatic bell switch circuit in an orchard to repel wild animals from attacking the crops at night. So the potential difference RS must be at least 12 volt. So the V here, okay, I will name this at 1. Everything here is 1. The resistance here is 1. So this is a special type of resistor called light dependent resistor, but I name it 2 easy. So therefore here will be V2 can. Okay, so this V1 must be minimum 12 volt. Now what is the resistance of the LDR? This means they want me to find R2 to ring the bell. So actually this is a potential divider circuit. Now basically there is a formula under this, and a lot of times students do not know how to derive out the equation. The formula is not given in the formula list. So now teacher guide you all the idea. I always tell students, if you don't see so many parts, okay, or if you just look at this alone, okay, it's actually back to some sort of like series circuit. Notice or not? So current should be the same. But then voltage is what? Voltage is V1 plus V2. Similarly, what is total R? R1 plus R2. Okay, but this transistor topic, they particularly memang they focus on the idea of resistor. You have special type resistor, like dependent resistor, where they actually depends on, they are affected by light. So if it is bright, the resistance is low. If it is dark, the resistance is high. Same go for thermistor, another type of sensitive to heat punya resistor. So therefore, in the equation, right, we need to compare the idea. And basically, the voltage is across the resistor one, they are directly proportional one. So I always tell students actually to form the equation not hard. You can form two equations. So the first one is V1 over total voltage. This is total voltage. It's supposed to be what? R1 over total R as well. Correct? Then hence I will have V1 equals to what? R1 over R1 plus R2, the whole thing times with the total voltage. Let's finish. Or if I want to have the idea of V2 then. So the idea is similar, V2 over total V equals to what? R2 over total R. So everything is same. Notice or not? Just that when this is, the V is 2, my R is 2, that's it. Can, right? But then the bottom is total, V is total. So this is the equation for you to do the calculation. So if you have V1, you also can have V21. Why? Just now I say already. 15 equals to 12 plus what? 3. So your V2 is 3. So you can use any of this equation to solve it. Okay. So I will use this one. So my V1 is 12. Your R1 is what? 2000 ohm. Kilo means 1000. So I always tell students you change it. Then total R. Total R is 2000 plus R2. I don't know the R2 I want to find R2. R2 is this is also the R. And then what is your total V? Careful, total V is here. 15. Then again is the max part already. So normally I will encourage students to move the one that divide right on to the other side, become multiplications. So you multiply, you have what? 24,000 plus 12 R2 equals to what? 2,000 times 15, you get 30,000. So 12 R2 is actually 6,000. So 6,000 divided by 12, you get 500 ohm. So I hope that through this question, you all know how to calculate the idea for this potential divider already. 36. Diagram 30 shows the curve graph for radioactive decay for J and K. So this is called decay curve. So which of the following statement is true? They want to find out the correct one. So this, which one decay faster? Generally K decay faster. J decay slow. Well, how come it's faster? As you can see, the half-life for A is shorter. Half-life, T half. This one longer. So A, radioactive material K decay faster than J. Wrong, slower. Okay, then J decay faster. Number 36. Sorry. K decay faster. Sorry, I just see wrongly already. So memang K decay faster. Correct already. J decay faster, wrong. Okay. A is the value of half-life for K. A is K. Then B is for J. B is for J. So that's why C and D also wrong. So the answer is A. The answer is A. So we proceed to question 37. 37. Diagram 31 show the structure of the moderator in nuclear reactor. What is the function of moderator? So for information, they want the function of moderator. So moderator is used to slow down the fast-moving neutron. Slow down. So that's why the answer is A. So absorb heat energy from chain reaction, not the idea. Control the rate of reaction. Control rate of reaction is from this control rod, which is made by boron. Act as field one is the uranium rod lah. So also nothing to do with moderator. So the answer is A, under nuclear energy. Number 38. Which of the following graph is true about the relationship between energy and wavelength for the light spectrum? So under the idea of quantum physics, energy is actually directly proportional to frequency. That's why we have the equation photon energy equals to HF. But then now they want the idea of this wavelength. So we also have you're supposed to know the idea whereby we can relate the idea of frequency and wavelength and speed of light, okay, which is C equals to F lambda. So F equals to C over lambda. So if I were to replace the F with C over lambda, right? So hence, what is the relationship between energy and the wavelength? They are inversely proportional. So now the graph is E versus lambda. So that's why the answer is D lah. So this shape is called inversely proportional. 39. Diagram 32 show a metal illuminated by the beam of light at certain frequency. Then electrons from the metal is emitted. So what is the name of the emitted electron? So this electron also specifically called what? Photoelectrons. Why they call photoelectrons? Because the light here is in terms of particles form. Memang they call photon energy. Where they are in the particle form. So when they hit the electron using one photon, so that's why and last they call photoelectrons. So the answer is D. Okay, and then last questions. Which of the following is true regarding the Einstein photoelectric theory? So under Einstein photoelectric theory, we have the equation of what? Photon energy is the sum of work function plus K max. Okay, so the higher the frequency, so this threshold frequency is under the work function, and they're supposed to be directly proportional. So it's supposed to be higher, so lower is strong. At the threshold frequency, electrons are emitted with low kinetic energy. Not correct idea. Einstein photoelectric equation is accordance to the principle of conservation of energy. Correct, because the energy here should be equal to the total energy here. And lastly, the more the intensity, the more the kinetic energy. Wrong. We are not about the intensity idea, but it's about the frequency. Higher frequency, higher kinetic energy. So at last, the answer is C lah. So just for your understanding, memang under your textbook, they have this idea one. This Einstein photoelectric equation is accordance to the principle of conservation of energy. So this is the whole idea about this topic. So yeah, we again finished all the 40 questions. Okay, so teacher, hope you benefit from all the explanation given. Okay, thank you, class. Bye-bye. Okay, so for question 30, diagram 25 shows a current carrying copper frame that is repelled when placing in a magnetic field. So what rules is used to determine the direction of motion of the copper frame? Now, so for this idea, you should know that the wire given the copper frame, there is a current that flow through. So the moment you have current flow through, right, okay, that produce this magnetic field and interact with the magnetic field from the permanent magnet, this is the idea of catapult field. Okay, so I always tell students, how to remember the Fleming left and right, right? So you have the idea of dynamo and also motor, right? Okay, so motor is all the concept on catapult field, and then dynamo is on the idea of electromagnetic induction, where you change the idea of motor is what? You supply electric current, okay? Then you change to this kinetic energy, whereas dynamo is vice versa. Kinetic energy become electrical energy. So as you can see the wording here, M mole. So that's why this mole is located left. So that's why we are using Fleming left hands rule. Also the answer for 30 is B.